Yeah, hi. Welcome to this video. This video is about strength of materials, or you can also solve it as mechanics of solids, MOS subject. So this subject I am dealing since 5 to 6 times I have dealt with this, and also this material is prepared by one of my friend. Very good experience. He's also having 10 years of experience in this mechanics of solids. So here, let me discuss some important questions I have prepared for like 10 questions, 10 to 15 questions almost in 1 unit I am taking. So that the students who have not attended can understand the basics of this mechanics of solids. Students who are not coming regularly are coming regularly also, but did not understand some concept in the class, they can also understand here. So let me take the first question, not wasting the time. Here, define stress and strain. So this is 2 marks questions for general knowledge. For your basic knowledge, I am discussing. So what is stress? The force of resistance per unit area offered by a body here is called as a stress. So what is this? So it the force of resistance per unit area of offered by a body against a deformation is known as a stress. So stress is the symbol of stress is here. I am sigma. So what is sigma is load by area. So what is the load? The unit load acting per unit area also we can call it as. Okay. So the force of resistance per unit area, that area, the body which is there, it is offering a resistance that is called as stress. It does not allow the area to deform. It's a shape which is called as stress. So it is what is the load acting upon that area. If it is more load is acting on that area, then that will get deformed. Otherwise, it will not get deformed. So this is the simple definition of a stress. Now define strain. In this question only, the concept is strain. As per the definition I am taking, the ratio of change in the dimensions to the original dimensions is known as a strain. So here you are load per area means you are talking about force. In the strain, you are talking about dimensions, change in the length, change in the dimension, change in the breadth, change in the diameter. Like that, we are going to deal. So here, the ratio of change in dimensions, any dimensions, for example, length, breadth, depth, 3 dimensions will be having. To the original dimension is known as strain here. So strain E is equal to change in the dimension by original dimension. For example, it can be length. For example, it can be diameter. For example, it can be here breadth. Here I am taking change in the length by original length. That is delta L by L. So which is called as strain. So change in the length by original length. So define what is a tensile stress and tensile strain. So what is the tensile stress and tensile strain you are taking here? Tensile stress. What is tensile stress? The tensile, the stress induced. Generally, tensile means pulling force. Generally, tensile means here this body is here. This body is pulled by some force P on both the sides. This is an example of tensile stress. The stress induced in a body, so stress is coming induced in the body when subjected to two equal and opposite poles. So you are giving two opposite and equal forces as shown in the figure, as a result of which there is an increase in the length. So increase in the length will happen. So if this length is increasing, the width is decreasing here in the tensile force you can observe. So what is the formula, mathematical formula? Tensile stress is equal to tensile load upon the area. So this is the tensile load P here and P here acting on this area of the body. So it is given by sigma is equal to P by force. So tensile force is related to stress formula also. There also we have discussed force by area. Here also we are saying that this is a tensile load upon area. So these are almost same one. They are talking about the forces. So tensile strain, what is happening to the tensile strain? The ratio of increase in the length to the original length. See, my strain, stress is there. What will happen to strain is some change is there. That is called as strain. E is equal to increase in the length. by original length. So length is increasing in the strain. You can say that automatically. That is the strain. So stress is directly proportional to strain. So if stress is there in the body, definitely strain takes place in the body. So third question, if I am not wrong, I am taking the third question. Define compressive stresses and compressive strains. So what is the compressive stresses and compressive strains? So compressive stresses means compressive means here the name itself says the compression of a body, ma'am. So compression of a body we are taking. Tensile means opposite of compression force, that is pulling of a body. Here compressing means you are compressing the body. Okay, that is the compressive stress. So let me take the definition here, ma. The stress induced in a body when subjected to two equal and opposite pushers. So two opposite pusher should be there. Here, okay, here in the diagram you can see ma, two opposite forces are pushing the body. Okay, it is decreasing in the length ma, here increasing in the width takes place as per the diagram. As a result of there is a decrease in the length and known as compressive stress. So compressive stress is equal to compressive load which is acting on the body upon the area. So sigma is equal to P by A. So compressive strain, what will happen? Definitely there is a decrease in the length. What happens when you apply? So they are already said that it is a decrease in the length ma here. So when it is a decrease in the length here, so compressive strain E is given by decrease in the length upon original length. So delta L upon L. So fourth question, if you say define volumetric strain, the ratio of change in the volume to the original volume is known as volumetric strain. The ratio of the volumetric means you are going to take x-axis, y-axis, and z-axis in the three axis, known as volumetric strain. Volumetric strain, V volume is equal to change in the volume upon original volume. So volumetric strain E volume is equal to delta V by V. So change in the volume upon original volume. So state Hooke's law. So very important ma. A scientist is Hooke's law, one who is saying that stress is directly proportional to strain. If you remove this directly proportional here, sigma is equal to some constant you can take E here. E capital E of E. This capital E is equal to sigma by E, stress upon stress. So if stress in a body increases, strain in the body decreases. So vice versa. So this E is called as Young's modulus ma in the following question. So definition I will take. Hooke's law states that when a material is loaded within the elastic limit, so definitely you have to work within the elastic limit only. You cannot go to plastic region. If you are going to plastic region, that material will not come to its original place. When you are inside the elastic limit only, that body will be regained to its original shape and you have to apply load within its elastic limit. This is a definition set by Hooke's law where the stress is proportional to strain. Stress is proportional to strain means the body is in the elastic region, not plastic region. What is Young's modulus or modulus of elasticity? So as usually before, in the previous question, I have said that E is represented by Young's modulus. It is a one of the constant you can say, or modulus of elasticity also you can say. Sometimes the ratio of E is equal to tensile stress upon tensile stress or compressive stress upon compressive stress. Young's modulus E is equal to sigma by E. So as usually before you have discussed here also in the fifth question, that is capital E is equal to sigma by cap small e. So let me take the definition. The ratio of tensile stress or compressive stress to the corresponding strain is a constant. So tensile stress upon compressive strain if you are taking, it is constant. This ratio is known as Young's modulus or modulus of elasticity. Now coming to seventh question, what is the modulus of rigidity or shear modulus? The ratio of shear stress to shear strain within the elastic limit is known as modulus rigidity. Rigidity means what ma? It is rigid, it will not make any motion or movement in the body. So modulus of rigidity should be So it is represented by C or N. So C is equal to shear stress upon shear strain. C or G or N. Usually you can say that modulus of rigidity should be represented by I, but not I. R here. Here represented by C, G, N. That is shear stress is equal to represented by tau and shear strain is equal to 5. So this is the definition beautifully said for that previous question. Now taking the next question, what is the working stress and factor of safety? See, for everything, we have to be applying factor of safety and we need to have a working stress. Now, what is working stress is it is the safe stress taken within the elastic range of the material. So, safe stress is that where a body will not change in its shape or size. It is the ratio of ultimate stress to the factor of safety. This is the working stress or breaking stress. You can say ultimate stress upon factor of safety. Ultimate stress you can apply on the body, but take care of the factor of safety. Now, what is factor of safety? It is the definition beautifully said here, if I am not wrong. It is the number used to determine the working stress. So, what is that? It is the number used to determine the working stress. So, ultimate stress upon the working stress is called as, it is ultimate stress by working stress is called as factor of safety. So, here from this formula is derived. So it is the ratio of ultimate stress to the working stress. Here, this working stress is coming down. This factor of safety is going here. Then it is ultimate stress upon working stress. So it is beautifully explained in the Hooke's law. So define ninth question: longitudinal strain and lateral strain. What is longitudinal strain and what is a lateral strain? The question itself is saying the answer here. The longitudinal strain you can see here, it is given by formula small e is equal to strain is given by small e is equal to change in the length delta L by original length, because longitudinal means lengthwise it is telling. It is defined as ratio of increase in the length of a bar in the direction of applied force to the out of the original length. Therefore, longitudinal strain E is equal to delta L upon L. So, this is the longitudinal strain. Lateral strain is given by, see, my length is increasing or decreasing, opposite breadth or depth should increase or decrease, vice versa. So, if you are taking lateral strain, here E is equal to change in the diameter upon the original diameter or change in the breadth upon the original breadth. So lateral strain is it is defined as ratio of decrease in the length of the bar in the perpendicular direction of applied load to that of the original length. Lateral strain E is equal to delta D by D or delta B. What is the Poisson's ratio? So next is Poisson's ratio is the next topic. The ratio of lateral strain to that of the longitudinal strain is called Poisson's ratio. The ratio of lateral strain, so laterally and longitudinally. So longitudinally is lengthwise, laterally is before I am telling you, laterally here also you can say breadth or depth. The ratio of lateral strength upon the longitudinal strength. So length is coming down, that is called as Poisson's length in any object in this mechanics of solid we can define it. The 11th question, define thermal stresses. What are the thermal stresses? Thermal stresses, the name itself says that any thermal activity in the body, if any temperature is given in the body, what is happening? It is freely expanding or it is not freely expanding. If it is freely expanding, not a problem, but if it is not freely expanding, then there exists the change in the body. So thermal stressors are the stressors induced in the body due to change in the temperature. If there is you are heating some iron rod, if it is freely expanding, so no problem. So you can say the wires which are there, electric pole wires are there. In the summer, due to the heat, what happens? They are expanded, They are expanded and they come down in the roads. You can see, they are somewhat their length is okay. The length is very loose, because heating makes them free. So in the winter season or winter season, you can see they are uh, very tight. Okay, so because it depends upon the that is called as best example for thermal stresses I can give my here. Thermal stresses, if you are applying thermal stresses to any body, it is free to expand or not. That is the main case here. If it is free to expand, no problem. If it is not freely expanded, then you have to take the constant and the formula for that one. Define principal planes. So what is principal planes means? Generally in the plane where there is no stresses, when there is no stresses, then what happens here? You will having a when a normal stresses acting on a principal plane are known as principal stresses, while a plane at which shear strain is all zero is called principal strain. So what is the principal plane? Principal planes means no shear stress. There is no shear stress is called as a zero shear stress is called a principal plane. Principal define next question principal stresses and principal strains. The normal stresses if you are taking acting on the principal plane are known as principal stresses. Normal stresses are there. If you are taking in a normal stresses, now for example, you can take here so your body is there like this. It is a normal stress here. So this is a 90 degrees line. You can say this is a normal stressor acting on a principal plane. If this is a plane I am taking here, if it is a normal is there, like line is there acting. Okay, this is called as a principal stressors. What is principal plane? While a plane at which shear stress is zero. See, no shear stress. Shear stress, no shear stress is equal to zero here. Definitely, when there is no stress, there will be no strain also. So you can this one see here this one. Okay, next question. I am if I am not wrong, I will go to next question. So what it is telling is here. What is a direct stressor? So direct stressors is nothing but the stress at which are acting normal to the plane. So here I am taking no ma. Here I have said you. So this is a normal 90 degrees anything acting. If you are taking a circle ma, if you are taking some circle, this is a tangential force, this is a normal force N and this is a T force means a tangential force here. So always this normal force you can test. So this is a direct force acting here. The stress which are acting normal to the plane are called direct forces. So what is a Morse circle? So Morse circle also you can take Morse circle also you can take here. Next question, 15th question. Define what is Morse circle. So Morse circle is a graphically method of finding normal, tangent and resultant forces. So normally you can take a Morse circle. It is like this ma. So what is happening? It is like this. So it is given like this. A circle is drawn. In this circle, you have to find out what is normal force, what is tangential force, and what is resultant force R. So for example, this is the force R, this is the force and normal, this is the tangent force. So this is the Morse circle diagram. Here because it is 2 marks, I have not given anything here. But Morse circle is the graphical method of finding normal N and then tangential force T and then resultant force R. If I am not right, this is the Morse circle I am taking here. So, if I am not wrong, I am going to the next question also. Ma. What is happening is sixth question. Define strain energy. What is strain energy? Whenever a body is strained, means if you are overloading a body, it will get strained. Ma. The energy is absorbed in the body. The some extra energy is given that will be absorbed by the body. The energy which is absorbed in the body due to straining effect is known as strain body. So that body gets strained ma, due to the extra work given to that extra load given to that body, that is called as strain energy. 17th question you can see define resilience and proof resilience. Now this is a strain energy concept started ma here resilience. This is all springs you can say ma. This will bring you a beautiful this one about springs ma. You can take springs. This energy is absorbed by springs ma. You can say okay. So like this, it will be there. Springs. This energy is absorbed here, ma. Here, this is called as whatever the energy is there. This springs coils will absorb, ma. in the spring. That is called as strain energy. So this is a strain. If you are putting load here on this one, so this is energy is a damp forces. So it is what is the 17th question? Resilience means the total strain energy stored in a body. So if you are putting spring ma, you are compressing this spring from the both these sides ma. What happens is you are compressing from this side and also you are compressing from upper side and lower side. So here resilience will be developed. It is stored in the body only. So the maximum strain energy stored in the body is known as proof resilience. So what is proof resilience means maximum resilience. Maximum resilience stored in the body. Maximum R is called as proof of resilience. And so this is define modulus of resilience. So what is the modulus of resilience? So this is also given by modulus of resilience is equal to proof resilience upon volume of the body. What is proof resilience? Is maximum resilience stored here by volume of the body. So what is the volume of the body? So that is given upon x by y axis. In the x here upper proof resilience by volume of the body. So it is defined as a proof resilience of a material per unit volume modulus of rigidity. So this is the last question of this unit mark. So if I am not wrong, I will clean this one. So I hope you have understand. So next it is like other is there. Unit 2 is there. Next here unit 1. So 18 questions beautifully 18 questions are covered in the Unit 1 ma. I hope you have understand all these concepts, basic concepts only I am telling, not heavy concepts to the students who are not having minimum idea. It is helpful for them. So I hope you understand it. And thank you, ma. Thank you for your this one. So any suggestions you can comment and like and subscribe to this video. Thank you, ma. Thank you very much.